Hello and welcome back to the CCNA journey with me, Ryan, and in this section we're going to continue with Etherchannels, which is part of the network access blueprint on the CCNA, and this is part 2. In part 1 we looked at what an Etherchannel actually gives us, the benefits of using an Etherchannel, and we also looked at how to configure an Etherchannel for layer 2 within Packet Tracer. And in this video we're going to continue on our knowledge and we're going to look at specifically how to configure a layer 3 Etherchannel within Packet Tracer, and we're also going to talk about some of the order of operations issues that you can come across with Etherchannels, and how in a production environment we need to be a bit careful and keep our wits about us when it comes to Etherchannels. For those who don't know, you can contact me here on YouTube, you can connect on LinkedIn, Twitter or Facebook. So Etherchannel, as I said before, I'll mention it again, is a logical interface which represents multiple physical interfaces. And effectively we're just turning the port from layer 2 to layer 3. So that's all we're doing here, and it kind of warrants a bit of discussion around what I mean by that. And this is why, let me just bring up a pen, it's important that we just take a time out and just have a discussion about what I mean by layer 3. Now in this scenario we're going to put together, we're actually going to have switches inside Packet Tracer, and we're actually going to use layer 3 switches. And the reason I'm going to use layer 3 switches is because I want to show you a new command yet to be introduced, which is the no switchport command. Now effectively, some of you may or may not know what a switchport is, but of course on a switch we have multiple ports, and if they're performing switching then they're referred to as a switch port. Well, if you're working with a layer 3 switch, or also called a multi-layer switch, then you can actually turn off the switching functionality by putting a no in front of it, and by turning off the switch port it actually changes it to a layer 3 routed port. And the difference being is then we have things like the IP address that we can put directly on the interface just like a router, rather than having to use something called an SVI, which is a switched virtual interface, or a VLAN interface. So I know that might if that's new to you, that might be a bit confusing, but I'll show you what I mean when we're in the Packet Tracer. But effectively what we're doing is, if our switch allows us, we're basically saying that this port on this switch here, no longer do we want it to be part of a switch. Instead we want to give it full router or full routing capabilities, okay, or router and routing for a lot of you out there. So that's what we're doing here. Okay, we're effectively changing the actual port method. Now, one thing we have to be really careful of here, and that is the order of operations. And what I mean by that is, if we build an Etherchannel, okay, let's just go back to kind of what we learned in the first video. We know an Etherchannel is 2 physical ports, and those 2 physical ports are bundled to represent 1 logical port. And of course, as I said previously in the last video, this could be 8 physical links. This could be up to 8 physical links anyway. And up to 8 physical links being active, we could actually have 16 ready to participate in an Etherchannel. So there's a lot that could be done here. But let's just say, for example, in this, we've only got 2 physical links. We've configured those physical links, and we've actually made it as a layer 2 Etherchannel, just like we did in the last video. Well, we also know from the last video that an Etherchannel has to match on certain attributes and criterias in order to be put into an Etherchannel. So, for example, we said that each port has to make sure that we have the right VLAN allowed list. We have to make sure the duplex is the same. We have to make sure that the speed is the same. So we have to go through this like a series of checks effectively, and only when they're all the same will the actual bundle or the channel will actually build correctly. Well, if we want to make this to a layer 3, I cannot just go in to this physical port and say no switch port. Because if I were to do that, what happens? Well, I break the channel, because this port and this port do not agree on the same configuration. I configured one as a layer 3 port, and I've got one still as a layer 2 port. And no matter how quick I do that, one will be configured before the other. If I paste the config in, one will still be configured before the other. And the order of operations is vital here. So to move a layer 2 channel to a layer 3 channel, and obviously that doesn't happen very often in production, but if you ever need to do it, what's recommended is to shut down this port, shut down this port, shut down this port, shut down this port. You would take off the Ether channel configurations, you would make it a layer 3, and you would re-add the Ether channel. So don't, at least in production, go around changing a lot of the configuration of an Ether channel, not at the physical port. Always change it at the logical port. And if you want to change how the physical underlying Ether channel is operating once it's configured, then you need to take down the ports, reconfigure it, and bring it back up. If you try to configure it without doing that order of operations, you will run into all sorts of problems. You would run into problems with spanning tree, because spanning tree, the spanning tree protocol will start sending out traffic one way and getting a response back, and we'll start to realize that there's some sort of loop going on. Ports will start bouncing. You will see ports go into error disabled state. The Ether channel guard, which kind of helps prevent against this, Ether channel guard will start kicking up fuss. So you'll run into lots of different problems. So order of operation is important here, and that's why when we build our Ether channels, we build them at layer 2 or layer 3, depending on the requirements, and we keep them that way in most scenarios. Very rarely do you have to move from a layer 2 Ether channel to a layer 3, unless you're completely changing your design. Normally you kind of just a case of, the most common thing with an Ether channel is you add an additional port in. So maybe this 3, maybe you add another 2 more ports, so you've now got a 4-port Ether channel. Or another common thing is you're just adding additional VLANs, or you're just changing something specific to that interface, like quality of service. All of that is done on the Ether channel, not the physical port. So a lot of information to take in there, but effectively what I'm saying is that if you want to change an Ether channel from layer 2 to layer 3, or from layer 3 to layer 2, it's best to tear down your Ether channel, change the underlying ports, whether that's turning on switchport or turning off switchport, and then building the Ether channel back up. So that's the rule of the order of operations. Very straightforward. If you're not sure what an Ether channel is, or not sure what I'm talking about so far, go back, watch my previous video. At this point, the only thing that should be confusing to you, if this is new, is the switchport element. Everything else has been covered. And maybe the talk of error disabled and spanning tree, because that's not yet something that we've talked about either. That's coming up as a fun topic after Ether channels. And my next comment here on the slide is actually, oh, there's my graphic, is a sleeping beast. So, be careful with Ether channel. A lot of times you can do Ether channels and will cause an outage, even though there are resilient ports. If you break the Ether channel, you will cause problems. Because remember, let's say, again, let's just give you another example. Let's say we have a production environment, and your production environment is connected 2 devices together. Well, all of the config for these interfaces live on the logical interface. So when you start changing the physical interface does not tell the logical interface. The logical interface only pushes the config down to the physical. That's why you end up in order of operations problems. But effectively, when you're in production, try to avoid making any, well, you should never make any changes without effectively a change control or approval to the physical interface of an Ether channel. It's just asking for mistakes, and it's a very it's a thing where you learn from mistakes, because Ether channels can be very like I said, a sleeping beast, very unforgiving. The other thing from my experience with the Ether channel is across platforms. So for example, we know we have, or maybe you don't know, but there's Nexus, which is a Cisco switching platform for the data center from Cisco. We also have this classic Catalyst. We also have things like completely different vendors. And when you start doing different ways of performing Ether channels between these solutions, sometimes you end up running into, again, odd behaviors. Even though LACP is open standard, not all of them kind of do the back end correctly. Now, that's not so much of an issue with an Ether channel as it is with something called an MLAG. And an MLAG is a CCNP topic, but I'll give you a little bit of an insight. but that's a multi-chassis link aggregation. And this is where, you ready for this? This is where we have a switch over here, a switch here, and then let's say, for example, we have our server, right? Well, in the last video when we looked at ether channels, we done this, didn't we? We done an ether channel between our servers or between our switches, and it was 1-to-1. Well, what happens if this switch goes down? This server here goes offline. Well, what we can do with a MLAG, and you can probably guess this, is we can actually run one physical port this way, one physical port that way, allow the switches to communicate, and then we can run a channel, an ether channel, across two physical switches independent towards a server. So ether channels get interesting as you go up the ladder. I just thought I'd give you an insight. Don't worry about MLAG. It's definitely not on the CCNA. It's not on the blueprint. It's not mentioned. All we have to worry about for the CCNA as far as ether channels are concerned, and we'll get onto the packet tracer in a second. Do I know how to configure a layer 2 ether channel? Do I know how to configure a layer 3 ether channel? Do I understand what the LACP protocol is doing? So it's an open standard protocol that allows both ends to negotiate an ether channel. Do I also know how to show the output of an ether channel using the show ether channel summary, which we've checked out in the last video and we will check out again in a minute. And then finally, the last bit is, how do I configure an ether channel without, so that's without without LACP. And that is something that we also can show you very quickly, and that's where we use something called the ON method, where no negotiation is used. And of course, if we don't negotiate both ends of a channel and both ends don't match, we end up in all sorts of problems, which is why LACP is part of the CCNA and is the recommended way. It's not recommended to just turn on your ether channel. Okay, so here we are. We're actually inside EvenG. EvenG is a emulator that allows you to emulate a lot of virtual devices, including Cisco. And I've used it here to emulate some virtual Cisco switches. You can see that I have 4 switches here, but really all we're interested in are these 2 switches up the top. And the 2 switches have gig 00 to 00 and 02 to 02. So we'll go ahead and we're going to configure our layer 3 port channel between these devices. Now you might be wondering at this point, what happened to Packet Tracer? Well, I'm using Packet Tracer version 7.4, and I tried recording how to create an ether channel in layer 3, and I ran into lots of problems where the switchport command didn't actually, well, it did disable the switchport functionality, but it didn't show it correctly. And I also ran into a problem with actually sending ICMP or ping traffic across the link. So I'd rather not show you a buggy output of what should happen and instead kind of show you something that is correct. So in that case, I've spun up the EvenG instance. I've got 2 Cisco iOS images for switching, and I have them set up now. So let's go ahead and have a look into this. We can first of all look at the switchport command. So we look at the switchport command, we can instantly see it is enabled. So this tells us it's a layer 2 port, and we see all the information that we expect to see as part of a layer 2 port. Kind of VLAN information, trunk in, voice VLANs, anything that's kind of relevant will be here in this show output with this switchport command. Now, I said we want to disable the layer 2, and by disabling layer 2, the port for the switch becomes layer 3. And what I mean by that is if we go to the gig 00 in the configuration terminal, so config terminal, interface 00, IP address, notice I can't put an IP address on this interface. But if I go ahead and actually do no switchport, I can now put an IP address on the interface. But what I can also do is, let's do that show command again. You can see now it says switchport disabled. And that's the only output we have, because all of the layer 2 options that were associated with this switchport are now gone because the port is no longer switching. Let's do the same with gig 02. And then let's go across to switch 2 and do the same for its 2 ports. So just bring this one up so we can see it. So now we have all 4 ports in routing mode per se. Now what we can do is create the Ether channel just like we did in the previous video for layer 2. So let's go to the actual interfaces and get that configured. And we do that using the channel group command. We give the channel group a locally significant number just to identify it if we have multiple channel groups or multiple Ether channels. And then we specify the mode. And then, as I said previously in the last video, we've got different modes. We have the LACP, the Link Aggregation Control Protocol, and the PAGP, the Port Aggregation Protocol. The PAGP is Cisco proprietary. The LACP is open standard. LACP is the only one mentioned on the blueprint, but it's probably best to be aware of the PAGP. And we can also see that there's an on method here. And on effectively means don't use PAGP or LACP. Instead, don't negotiate the channel, just bring it up. I don't care what the other side's doing. I don't care if the other side is trying to form a channel with me. Just bring up the port. Bring it up, send traffic out of both links. But major issue here, if we have it configured on one side and no Ether channel on the other side, then you will end up in a loop situation. So on is rarely used. The only time on is kind of used in production is if PAGP and LACP is not supported with the other device. In this scenario, we're not doing that, so we can go ahead and use LACP as per the recommendation. But it's important to know you can form an Ether channel without either protocols. Now it also says that we have different options here. For LACP we've got active and we've also got passive. One side has to be active in order for LACP to form. Both sides could be active and that will still work. One side, any side can be active and that will work. If both sides are passive, that will not work. So you have to have a device actively sending out LACP messages. So let's go ahead and set this as active. And then what we're going to do is the same for the other interface. Now look at this. It says LACP is currently not enabled on remote port, so it's gone into the suspended state. So what that means is LACP has been sent across this link, switch 2 is not configured, so switch 1's been clever enough to suspend the port rather than causing a potential loop. So let's look at the Ether channel summary output. So again, kind of the main command for us here, we can see that we have R and D. So that means that we have layer 3. And in the previous video, you might remember it would be S and D, which was layer 2 for S. So S for switching, layer 2, R for routing, layer 3. And it was D means down. But obviously when this comes up, we hope to see it show as U, which is in use. So it'll be R, U. And in the last video, it was S, U. So just need to remember kind of what R and S means and what D and U means. So something just to keep in mind. And then we can go over to the right here and look at the ports, and we've got this lowercase s. And the lowercase s says to us that the port has been suspended. So it's been suspended because LACP packets have been actively sent out both these ports. No one got a response, so the switch knows that the other side is not set up for LACP. So let's go to the other side and do the same. Because we've already disabled those switch ports, let's move them into the actual group. Now what you'll find is you don't have to use the same group number at both sides, but you know, most people do to try to keep it kind of clean, but that might not always be possible. But you know, we'll see. Depends on kind of the scenario. Now what we can see, which is exactly what we expect, is no longer does it say suspended down here. Instead we actually see P, which is bundled. So that's brilliant. That's looking really good now. And then let's go ahead and put an IP address and see if we can ping across this link. Can I ping locally? Yes, I can. Can I ping remotely? Yes, I can. And if I look at the routing table, we can see the routing table shows port channel 1 as the interface. So there's our port channel configuration, the new logical interface that was created based on what we've done on the physical interface. So both physical interfaces has this channel group 1 mode active, and as soon as I put that on the physical interface, this one created port channel 1. And we can see that no switch port is inherited from the no switch port of the physical interfaces. And then, as I said in the last video, if we want to change this to layer 2 now, we would have to shut down both ports, physical ports, delete the port channel, re-add, change it to layer 2, re-add the port channel. It's the best way of doing it. Any other method, you run into all sorts of problems. So just to go over again what we've just talked about, to change an ether channel, to create a layer 3 ether channel, the key thing here is before we create the ether channel, we put the physical ports into no switch port, taking away the layer 2 capabilities and replacing it with the layer 3 capabilities. So then when we create the ether channel using the channel group command, we end up with a layer 3 ether channel. It's important that if you switch between ether channel modes, that you shut down the ports, you remove the config and re-add the config once you change the switch port method. Okay, if you don't shut down the ports, then you end up in LACP being suspended. You end up in, what's called transient loops as you do your config, which is small loops in the network, but it can cause a bit of an impact or a knock-on effect to other devices. It's best to do it clean, shut down that port, and do the initial configuration of deleting the channel, changing the switch port, creating the channel. And then we verify our config just like we did before with the show ether channel summary. In this case, we're looking for the R instead of the S to symbolize that this is now a routed port or a routed ether channel rather than a switched ether channel. We first of all went over how to create ether channels at layer 3. We said it's just essentially disabling that no switch port command and then following through the same process as before. We know why we need them. We need them because effectively an ether channel gives us multiple interfaces in a bundle, and we only have to do the config once, and then we can add and remove ports to that bundle in real time. We've talked about the benefits primarily in the last video, and we've really highlighted the pitfalls of configuring the ether channels due to the order of operations. So that's something to keep in mind there. And then we've also, I say here, within Packet Tracer. So just to kind of explain that, I was using a version of Packet Tracer. It was 7.4, I think it was, or 7.2. I'll put it in the description. But effectively, I couldn't send ICMP traffic between the layer 3 port channels once they were created. So instead of that, I used something called EvenG in this video. I will avoid using anything other than Packet Tracer for the CCNA because I find Packet Tracer does 99% of what we actually need, but unfortunately we do run across these little bugs with Packet Tracer. And I don't want you to see those bugs and it to confuse you on what it is that we're trying to achieve. So I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.